So this is the information for the Alum Lab Report. For page 1, I want the lab report form filled out. For pages 2 and on, notice I want all calculations. That means every calculation that you could do, I want to see it. And then on the last page, I just want the copy of the data from lab. So that way I can follow through with whatever data you have based on the calculations. So let's go ahead and get started. For part 1, you actually have to write down all 4 reactions. And those 4 reactions come from your lab procedure. I've written 2 of the 4 down. And what you have to do is you have to come up with a complete balanced chemical equation, which is right here. But that complete balanced chemical equation to produce alum, which is right here, notice the 2 that's here, that's only there to balance the chemical equation. What's noted here is actually the formula for alum, and you'll need to find the molar mass. That molar mass of alum, not aluminum, alum, is about 474 grams per mole, but you'll need to calculate that, including the 12 waters that are bound to it or coordinated to the potassium aluminum sulfate. Now, to get to that balanced equation, you're going to write down all 4 reactions, 2 of which I've written, and you're going to cancel anything that's on both sides. So I'm going to do that in blue. You'll notice here that I have 2 aluminum hydroxides, 2 potassium aluminum hydroxide on the right-hand side as a product. I also have it as a reactant on this side. Notice that it has the same formula and the same phase, and therefore I can cancel it on both sides. You're going to continue doing that also by noting, for example, that I have 6 waters here and I have 2 waters here, both in the same formula with the same phase. So I can get rid of these 2 waters, and that would simplify the 6 waters here to 4 waters. And I would continue doing that simplification and essentially canceling out what's on both sides in terms of formula and their phases, as long as those are the same. And what we end up with is this balanced equation right here. And this is important because that's part 1 of your lab, was actually to run those 4 reactions to get to the overall balanced equation through canceling on both sides. The second part is actually, the goal for that is to determine what is the limiting reactant. And how do we know that that's our goal? Because on the report form, ultimately what it asks for is the percent yield. And if you remember from class, when we talk in terms of percent yield, I'm going to bring it down here, that percent yield equation is equal to the actual amount of alum that you found, and that's the white powder that you made in lab. So you have that actual yield in grams, that's your experimental amount, divided by the theoretical yield in grams. And from class, you'll remember that anytime that we talk in terms of theoretical yield, that means we need to know what is the maximum amount of product that is formed. That gives us a hint that that's always based off the limiting reactant. The limiting reactant limits the amount of product formed. So what that means is that we've got to go back up here and notice we have aluminum, potassium hydroxide, and sulfuric acid in an excess of water. So we've got to figure out which of these 3, aluminum, potassium hydroxide, or sulfuric, is the limiting reactant. So to do that, remember, in order to compare one element to another in a balanced chemical equation or formula in a balanced chemical equation, we've got to first get to moles. So we've got grams of aluminum. So this first conversion, we go to the periodic table. So this is a periodic table conversion for aluminum. That's where I found that molar mass from the periodic table. And if we stop right there, that only tells us the number of moles of aluminum that we started with. It doesn't tell us anything about the maximum amount of the product formed. And in this case, we're interested in how much alum is formed. So to do that, we've got to do a balanced chemical equation conversion. And notice here, we end up with 2 moles of aluminum. And those 2 moles of aluminum produce 2 moles of alum. And that will get me to the answer of the number of moles of alum formed from 0.52 grams of aluminum. That doesn't tell me what the theoretical yield is, and it doesn't tell me which is the limiting reactant. I have to do that for all 3. But what you'll notice here is I've got potassium hydroxide in terms of molarity, and I've got a volume for it. And if you'll recall from class, molarity is actually moles per liter. So I've got 1.4 moles of potassium hydroxide per liter of solution. And so I've got to figure out how many moles of alum are formed. So I've got to get to moles of potassium hydroxide first. I used 25.0 mils. That will be different for you, potentially could be. But I'm going to convert it to liters in order to get to moles of potassium hydroxide. And now I can go to the balanced chemical equation up here. Note that for every 2 moles of potassium hydroxide, so I'm going to continue that on, how many moles of alum are produced? And so notice here, it's 2 moles of alum produced. I'm running out of a little bit of space. I'm going to write up here. And so you would have an answer here for moles of alum that are produced from the moles of potassium hydroxide that we started with. We're still not finished because we still need to do the same thing here with sulfuric acid, noting that this time we used 9 molar and I ended up using 10 mils. So I've got to get to, for this particular one, I've also got to get from moles of sulfuric acid to moles of alum. And once I do that, then I can compare all 3 of those. So I'm going to have to compare the moles of alum that are produced from the aluminum, the moles of alum that are produced from potassium hydroxide, and the moles of alum produced from sulfuric acid. What I will do is once I compare those 3, then ultimately I've got to figure out from those 3 which one of the 3, aluminum, potassium hydroxide, or sulfuric acid, produced the least amount of alum. And whichever one produced the least amount, guess what? That equals my limiting reactant, and I'm going to circle whichever one that is on my lab report form. Now, once you know you've got the least amount of alum, you'll write that one down because that one actually, so I'm going to make a note on here that that's my least amount. That least amount that's produced is the maximum amount that's produced or formed. And so as a result, that is actually equal to my theoretical yield. But notice it needs to be in grams. So I've got to do the conversion for every 1 mole of alum, and you will have the molar mass that you have found from above, and you'll place it right here. And then this would be your theoretical yield. that would then go into your percent yield equation. Because again, the limiting reactant always tells you the maximum amount of product that you can form. And that's why when you look at it and determine it, it is the least number of moles of alum in this case as the product. And that will be for your lab report.